This is the Unit 6 on circuits, and it's the extra practice for the parallel circuits. Now, as soon as you see parallel circuits means that there are optional paths for these coulombs to pass through. So if you notice in this circuit, you have a 9-volt battery, and the coulombs can move through this bulb, or they can move through that bulb. So you have two different paths, and because they have two different paths, each path has a voltage drop of 9 volts. Okay, so there are the answers over here, but I'm just going to walk through and just try to jog your memory a little bit. So if this is a 9-volt battery, when the charges go through this bulb, there's going to be a loss of 9 joules per coulomb. And that's where they get the 9 joules here for each coulomb, and also here with light bulb 2. Now, here in number 1, every second, 5 coulombs pass through the light bulb every second. So here I wrote C1, that's the current through bulb 1, is 5 coulombs per second, and it's 15 coulombs per second through light bulb 2. Now, the other thing that's important to realize is that if you have 5 coulombs here and 15 coulombs here, that means at point A and also over here is going to be the sum of these two. So here it would be 20 coulombs per second, and over here would also be 20 coulombs per second. And that's where the 20 breaks up into the 5 and the 15. Okay, now notice that when you calculate the resistance, we know that the voltage is 9, and we know that the current is 5. So we're using this formula V equals C times R. Now, another form of that is current is voltage over resistance. Usually you'll see this as I equals V over R if you look it up online. And when we talked about it earlier before the break, this is the equation we used. I equals V over R. So I, remember, is coulombs per second. Voltage is joules per coulomb, and R is measured in resistance, which is ohms. And here, then, if we have the voltage is 9 and the current through bulb 1 is 5, then you can take 9 divided by 5 and get 1.8. You can also use this formula directly. It would be 9 over 5. And then this would be 9 over 15. And notice bulb 2 has a greater current. The reason it has a greater current is because it has a smaller resistance. So if you have a smaller resistance, you're going to get a greater current there. Now, in part D, it says how many coulombs pass through A, B, and C? Well, here is where the current has not been divided yet, but at C, all through this part, this is going to be 5, and all through this part, it's going to be 15, and then the 5 and the 15 join up here, and you'll get 20 over there. Now, it wasn't asked in this question, but it might be on the quiz that you're going to have to take. So here's the 20, the 15, and the 5. Now, in part F, how many joules are being released every second? Joules per second is a unit of power, and power is measured in watts. Okay, so there's the formula here is power equals the current times the voltage. Now, the current is different for each one, even though the voltage is different. So, I'm sorry, the the voltage is the same, but the current is different. So you're going to get a different power here in the bulbs. Again, the current is different, but the voltage is the same. It's going to be 9 volts. Remember, whenever you have a parallel circuit, that voltage drop is going to be the same.